Now this question, it says a metallic sphere of radius 12 centimeter is melted, right? So when you melt something, the volume remains constant, and drawn into a wire whose radius of cross section is 16 centimeter. What is the length of the wire? See, understand, sphere we know, right? Sphere is of this shape. The volume of sphere is 4 by 3 pi r cube. And the wire is cylindrical, right? So this was sphere and wire is cylinder. Okay. Suppose the length of the wire is L, that will be taken as height of the cylinder. And the radius of cross section, so radius of cross section of the wire will be the radius of the cylinder. Now here it says radius of cross section is 16 centimeter. All right. So radius is 16 centimeter. Radius is this. All right. So now we have all the dimensions, and melting means the volume constant. So what we have to do is we simply take the sphere volume is equal to the wire. Now wire is cylindrical volume. Now sphere volume is 4 by 3 pi. Radius of sphere is 12. So 12 cube equal to wire volume will be, cylinder volume is pi r square h. So it is pi. And the radius of cylindrical wire is 16. So it is 16 square into h, that is the length of the cylinder or length of the wire. Instead of height of the cylinder, we'll take length of the wire. All right. So pi gets clearly cancelled. So from here you can see the value of L will be equal to 4 into 12 into 12 into 12. I'm not multiplying, I'm just opening 12 cube. Whole divide by 3 is already there into the 16 square goes to the other side in denominator. So let's write it as 16 into 16. Now what will happen? There will be a lot of cancellation that can be done. 3 cancels one of the 12 4 times. 1 4 and 1 4 16 cancels one of the 16s. 4 cancels 16 4 times and 12 3 times. Then another 4 cancels with last one of 12 3 times. So final answer will be 3 into 3, that is 9. And the units are in centimeter, so it is centimeter. So the required length of the wire is 9 centimeter. So this was a good, beautiful question. Okay. Now this question says the volume of a sphere is 38808 cubic centimeter or centimeter cube. Find its diameter and surface area. All right. The direct formula is for the volume of sphere is 4 by 3 pi r cube. That is given 38808. All right. So put the values 4 by 3. Into pi is 22 by 7 into r cube is equal to 38808. Simplify as much as possible. First let's do one thing, divide by 4. If you divide by 4 you will get 9702. Alright. Now if you look at this closely, 9702, 9 plus 0 is 9, 7 plus 2 is 9. So this number is divisible by 11, right? So 11 cancels 22 2 times and 11 cancels 9702. 882 times. Fantastic. And 2 cancels 882, 441 times. So what do we have here? We have r cube equal to 3 into 7. This 3 and 7 goes to the other side. So 3 into 7 into 441. Fantastic. 3 into 7 is 21. 441 is 21 square. So eventually it is 21 cube. Great. So what do we have? We have r cube equal to 21 cube. R cube equal to 21 cube. So that means R is equal to 21 centimeter. See, understand, in this chapter, there will be a lot of situation wherein you have to do a lot of calculation, but you have to do it a little smartly. You don't have to multiply the whole thing, right? You have to factorize because you have to find R cube. So you have to express this as a cube of something, so which we did here as 21 cube. You might not remember 21 cube. That is why I'm saying that. Okay. You have to factorize the things instead of multiplying. Now the question is find the diameter. The diameter is d, which is 2r, 2 times the radius. It is 2 into 21, that is 42 centimeter. Alright. The surface area of a sphere is a direct formula, and that is equal to 4 pi r square. So it is equal to 4 into, the value of pi is 22 by 7. R square is 21 square. So let's say it is 21 into 21. So 7 cancels one of the 21 3 times. Multiply it carefully. 4 into 22 is 88. Into 21 into 3 is 63. Which is equal to 5544. And it is area. So it will be centimeter square. Right. So the diameter is 42 centimeter. And the area is, surface area is 5544 centimeter square. Alright. Now the next question, it says how many spherical balls of radius 2 centimeter. So new radius is 2 centimeter. Melting a bigger ball. Now the bigger ball diameter is 8 centimeter. So diameter is 8 centimeter. So the old or original radius will be half of it, that is 4 centimeters. Alright. So original radius 4 centimeter. New radius 2 centimeter. Now the number of balls created will be straight away equal to original volume or original sphere volume divided by new volume of one ball. See, all the balls are same. From the statement it is clear that all the balls are of same size. So the volumes will also be the same. So the number of new balls will be equal to original total volume divided by volume of one ball. Now original volume will be equal to 4 by 3 pi r cube. This is sphere formula is, volume formula is 4 by 3 pi r cube. Okay. Now original radius is 4. So 4 by 3 pi into 4 cube divided by the volume of new ball. One new ball will be 4 by 3 pi and the new radius, that is 2 centimeters. So 2 cube. Oh great. So 4 by 3 pi is completely cancelled. Okay. We are left with 4 cube by 2 cube. One way is you can take the values of 4 cube and 2 cube, or what you can do is you can combine them. So it is 4 by 2 whole cube. Now 4 by 2 is 2, so it becomes 2 cube. Now 2 cube is 8, right? So this trick would have been really useful for larger numbers. If instead of 4 and 2, if there were very large numbers, first you should combine them in the same power and then you can simplify. So 2 cube is equal to 8. So that means the number of new balls formed is 8. Okay, now let's go to the next question. Now this question says a solid sphere and a solid hemisphere have the same total surface area. This is a really tricky question. Okay, find the ratio of their volumes. Let's see. If there is a solid sphere and the radius is r, the total surface area will be 4 pi r square. Okay, and if there is a solid hemisphere, all right. So this shaded portion is the flat surface of hemisphere. Hemisphere will have a curved surface area and a flat surface area. So the radius of this hemisphere is r1. Then its total area will be the half of the curved surface area, that is 2 pi r1 square, plus the flat surface area, that is pi r1 square, which is eventually 3 pi r1 square. Right? Read the question very carefully. The total surface area of hemisphere, you can directly memorize it as a formula, that is 3 pi r1 square. Okay. And the total surface area of a sphere, we already know it is 4 pi r square. The radius of sphere we have taken as r, and the radius of hemisphere we have taken as r1. The question is saying that they have the same total surface area. That means this 4 pi r square should be equal to 3 pi r1 square. So 4 pi r square is equal to 3 pi r1 square. So what we have from here is that r square upon r1 square is equal to 4 by 3. So if you take the square root, you will get r upon r1 equal to 2 upon root 3. Right? So we have the ratio of their radii. Now the question is saying find the ratio of their volumes. Okay, ratio of their volumes. Let's see. What is the volume of a sphere? The volume of sphere is 4 by 3 pi r cube. Whereas the volume of hemisphere will be half of this formula, that is 2 by 3 pi and its own radius, that in this case it is r1. So it is r1 cube. So in our question, the answer will be the ratio of volumes will be 4 by 3 pi r cube is to the volume of hemisphere, that will be 2 by 3 pi r1 cube. Alright. You can see very clearly that this pi and pi will get cancelled. 3 and 3 will get cancelled. 2 cancels 4 2 times. So it is equal to 2r cube is to r1 cube. Right. This can be written as 2 times r upon r1 whole cube. We already have r upon r1 as 2 by root 3. So we put it here 2 into 2 by root 3 whole cube. So this gives us 2 into 2 cube is 8. Root 3 cube will be root 3 into root 3 into root 3. So two of them will combine to become 3 and the third one will remain as it is. So it is 8 by 3 root 3. So the answer will be 8 into 2, 16 upon 3 root 3. So this is the required ratio, or you can present it as 16 is to 3 root 3. Alright. So this is the answer of this question. Okay. Now let's take up the last question. What does it say? It says a solid sphere of radius 15 centimeter is melted and recast into solid right circular cones of radius 2.5 centimeter and height 8 centimeter. Find the number of cones recast. Now this is a very beautiful question. Once again, the number of cones will be equal to original total volume divided by the volume of one new cone. That's it. Okay, because from the question it is clear that all the circular cones have the same size. So if I find the volume of one cone and divide the original total volume, we'll get the number of cones formed. Now original total volume will be taken for solid sphere, radius 15 centimeters. So I'll write it here. Alright, I'll write it here. It is 4 by 3 pi, radius is 15, so 15 cube. Okay, now divide by volume of one cone. Volume of cone formula is 1 by 3 pi r square h. Here it is 1 by 3 into pi. The radius of this cone is 2.5 centimeter. So it is 2.5 square into h. Height is 8 centimeter. So into 8. See, volume of sphere, we know the formula. It is equal to 4 by 3 pi r cube. R must be the radius of the sphere. Similarly, volume of cone is given as 1 by 3 pi r square h, where r is the radius of the cone and h is the radius, height of the cone. Alright. Now here if you see, 3 and 3 get cancelled, pi and pi get cancelled. Let's simplify. So we have 4, this 4 into 15 cube is 15 into 15 into 15. 2.5 square into 8, alright. Or what we could have done was 4 cancels 8. Anyways, we'll do it now. So it is 2.5 into 2.5 into 8. Now 4 cancels 8 2 times. Now 2.5 into 2 becomes 5. So let me write once more. 15 into 15 into 15 divide by 2.5 into this 2.5 into 2 will be 5. So 5 cancels 15 3 times. So we can take it as 15 into 15. In fact, let's remove the decimal. So it is 15 into 15 into 3 into 10 divided by 25. Alright, so this is easier. 5 cancels 25 5 times and 15 3 times. Another 5 cancels 15 3 times. So 3 into 3, 9 into 3, 27 into 10. That is 270 new cones will be formed. So this is the answer of this question. Alright, so this is where we have completed almost all types of questions that can be asked in mensuration related to area, lengths, perimeters, volumes, diagonals and everything else. Okay, you must go through the video once more, see if you have any problem. If you have any problem, you can always get back to us. Thank you so much. God bless you. Take care.